Dr. Danny Ho is currently an assistant professor in the Department of Supply Chain and Information Management at the Hang Seng University of Hong Kong, HSUHK. Previously, he held teaching and research positions at the Hong Kong Polytechnic University. And before entering academia, he worked for a global sourcing company providing merchandising services to leading retailers and brands worldwide. In the 2025-26 academic year, Dr. Ho serves as Program Director for the MSc in Global Supply Chain Management and Associate Director of the Supply Chain Excellence and Innovation Center at HSUHK. Dr. Ho holds a master's in science in management of manufacturing from Coventry University, UK, a Master of Philosophy in Industrial Engineering and Engineering Management from the Hong Kong University of Science and Technology, and a Doctor of Philosophy from the Hong Kong Polytechnic University. Dr. Ho is a member of the editorial board for the Digital Business Organization section of the Journal of Theoretical and Applied Electronic Commerce Research. Dr. Ho also serves as Associate Editor for the Sustainable Supply Chain Management section of Frontiers in Sustainability. His research interests include Belt and Road trade analysis using econometric and machine learning methods, global supply chain management, and sustainable development. His work has been published in international journals such as the International Journal of Production Research, Corporate Social Responsibility and Environmental Management, Journal of Shipping and Trade, and Sustainability, amongst others. Dr. Ho, welcome. Over to you.
Thank you. All right, so now I would like to share my screens. Right, so good morning, everyone. Welcome to the 5th WIMAYA International Conference. I'm Danny Ho from the Hang Seng University of Hong Kong, and I'm honored to speak with you today. My topic is AI-enabled circular economy, reshaping supply chains for sustainable growth. So why this topic? Because global supply chains are currently facing high pressure, including resource scarcity, climate change, and geopolitical tensions. They are forcing us to rethink how we create value. Circular economy offers a solution, and AI makes it scalable and intelligent. And these presentations will synthesize current research on how the powerful integration of AI and circular economy practices is defining value creation for supply chains. So specifically, I would like to share with you how they enable operations optimization across life cycle phases and their impact on firms' performance outcomes. So let's begin with some contextual information. So the overwhelming majority of the global economy still operates under a linear model. So this traditional model treats valuable resources as disposable assets, which generates significant environmental risk and promotes economic inefficiency. So according to the Circularity Gap Report 2024, nearly 92% of the global economy is still linear. So simply put, this take, make, and waste approach is not sustainable. What we need is transformation toward the circular economy. It replaces linear model. It focuses on reduction, reuse, refurbishment, and recycling of products and materials. The requirements for circular economy is driven by the urgent need to conserve resource amidst supply chain disruptions and resource scarcity. Circular economy also aims to combat climate change, pollution, and biodiversity loss through reducing waste and greenhouse gas emission, according to the United Nations Environment Programme. For researchers in supply chain management, the transition to circularity is not just about managing material flows. It represents a fundamental change. We would like to redesign value networks. And this shift delivers circular value creation, which functions as a growth strategy aimed at delivering sustainable performance outcomes across life cycle stages. To illustrate this tangible transformation, let's consider the example of sustainable beer. It is a concept where brewing utilizes surplus bread and transforming food waste effectively into a premium product. So this exemplifies the closed loop supply chains that move beyond disposal toward resource reintegration. And here is a successful case in the United Kingdom. And this company called Toast Brewing has been making beer with surplus bread since 2016. And this is circularity in action, turning food waste into value, helping a company to create new revenue streams, and more importantly, create positive impacts to the natural environment and the community. And all these performance outcomes are quantifiable and measurable. For example, on their website, they disclose environmental performance information like amount of food waste rescued, reduction of CO2 emissions, energy and water consumption, and so on and so forth. So more importantly, we would like to expand the scope and scale up the circular operations by using AI in different stages of a supply chain. AI functions as the brain of circular supply chains. For example, it optimizes collection of food waste, ensure quality compliance, helps to predict demand more accurately, and support operations. So this intelligence layer makes circular systems more adaptive and efficient. So with the use of AI, we can apply best circular practices across sectors, not just limited to the food industry, but also includes other sectors like fashion, electronics, and beyond. So now let us examine how AI is applied to major life cycle phases for circular economy, ranging from design to production, use and service phase, and finally, reverse logistics and end of life. So let's begin with design. In this phase, the objective is to create products for durability. We want to extend the life of the product. But we have to begin that from design. And practices like modular approach to product design also helps to prolong the life. So if one module of the product fails, we can easily just replace that part or that module, and then we just keep using the product. We would also like to design products for recyclability, like design for disassembly. Through design, if we are able to make the products that easily disassembled at the end of its life, that helps the recycling process and reducing environmental impact. But it has to start from design. So AI application in this phase include generative design, machine learning based material property predictions, AI-driven life cycle assessments. And moving to the second stage is about production. The goal is to optimize resource use and reduce waste and emissions during manufacturing. So AI application here involves process optimization using machine learning methods, creation of digital twins for circular flow simulations, and we can also apply computer visions for defect detection. These AI applications aims to make better products. So if the quality of a product can be improved, then there will be less waste to the environment. And so these applications rely on different techniques like reinforcement learning for scheduling, use of neural networks for quality control. And after production, it would be the use and service phase. The core objectives are to extend product life and enable shared models like product as a service. AI supports this phase through predictive maintenance, usage analytics for shared assets, and behavioral AI designed to encourage circular consumption. So different techniques like time series forecasting that involve LSTMs, algorithms, abnormality detections techniques can be used in this phase. And finally, is the reverse logistics and end-of-life phase. The objective is to recover materials and efficiently reintegrate them into the circular loops. Applications include automated sorting with computer vision, smart collections, routines, and recycling process optimization. Again, in here, we can make use of AI algorithms like neural networks for material identification, machine learning for route optimization. So in fact, the practices I just mentioned have been examined by some recent studies through the design and production stage. So if you're interested, you can refer to these different studies for details. And some studies focus on application of AI for circular economy in the use stage and the final stage, end of life. Again, if you are interested in these studies, you can read these papers for details. And in the literature, we find that some studies conducted systematic review of studies that focus on application of AI for circular economy. And these findings confirm the transformative potential of AI. So key findings include like AI supports reverse logistics, cycling, sustainable manufacturing. AI enables system optimization, better use of resource, predictive maintenance, and waste reduction. And by using AI, firms can better track emissions and improve automated waste sorting and smart water distribution. In addition to the review studies, there are also some recent empirical studies that demonstrate tangible benefits from using AI enabled circular practices in different contexts, including manufacturing, agricultural, and service sectors across countries. And both quantitative and qualitative methods have been applied by these empirical studies. Again, you can refer to them in the list for details. And across these different studies, several themes emerge. So I would like to briefly present them to you. First is AI is a core enabler of circular economy. And so, like I mentioned earlier, they point out that there are positive impacts AI can deliver to companies. But we would like to conduct further studies that focus on longitudinal approach to quantify AI's impact on the KPI over time across industries and countries. The second theme is these studies mention that AI is frequently used and integrated with other technologies like IoT for sensing, blockchain for traceability, and digital twins for simulation. So with the integration of these different tools, companies can enable high transparency and also improve loop closure. So further study may want to develop reference frameworks, reference architectures that specify data models, interfaces, and governance framework for integration of all these different technologies. And these studies also highlight the role of data-driven decision-making. So use of big data together with machine learning, companies can make better decisions, like develop optimize the route and improve the accounting for carbon reporting and resource planning. But we would like to do more, like create benchmark data sets and standardize evaluations metrics. And all studies note very strong sectorial patterns. From the findings, we know that the impacts and barriers differ by industry context. So we would like to, again, conduct more studies to build industry playbooks, specifying specific CE actions, AI technique for different sectors. And there are still other themes emerge from these different studies, like barriers for implementations and scaling up the operations. So they include factors like high energy and computational demands, uneven data quality and availability of required data, privacy constraints. And so I do believe, especially for developing economies, this high energy usage could be a high barrier. So we do believe that we want to conduct more research, for example, in developing greener AI models and approaches for CE practices. Other issues like ethical risk, governance issue. So we would like to join together with multiple parties like industry practitioners, policymakers, and other major stakeholders to develop this multi-stakeholder governance framework to ensure responsible AI use for circular economy. And these studies also highlight organizational change and adoption resistance. So future studies may want to examine different interventions, measures like financial, non-financial incentives to drive organizational readiness for using AI in circular economy. So some incentives, schemes or interventions, measures may work for large companies, but they may not be effective for SME. So more studies should differentiate effective mechanisms for companies with different size. And these studies also call for common CE metrics and AI maturity pathways to facilitate comparisons of effectiveness of CE practice and performance measurements across contexts. So at last, these studies show that many benefits demonstrates in pilots only, and also for large enterprises. So SME face resource and knowledge constraints. So future studies may want to focus on lightweight AI toolkits, sort of this DIY approach for SME. Now, we would like to transit to a key questions for business and management researchers. How do CE practices translate into firm performance? So from the literature, different mechanisms related to operations, finance, strategy, and social performance have been identified. So they include resource efficiency and input cost reduction, practices like internal recycling, substituting virgin with secondary materials to lower material procurement costs and improve financial performance. But these outcomes are moderated by different factors like the degree of CE adoption and firm size. And the second mechanism is operational efficiency and process innovation. Digital tools and IoT-enabled tracking systems can be used in different phases, like designs, reverse logistics, and they result in throughput gains, scrap reduction, shorter cycle times. But organizational agility and digital technology adoption are key moderators for these productivity gains. And some mechanisms focus on market practices like product as a service, leasing, refurbishment, and resale generate incremental and recurring service income. But moderators like market acceptance and effective pricing models could affect this relationship. And through practice like equal labels, take-back schemes, companies can achieve high brand equity and charge price premiums for targeted market segments. And some mechanisms focus on risks, like using multi-sourcing of secondary materials and localized circular loops helps to reduce supply risk and lead to steadier margins, especially during market volatility. But infrastructure readiness, supply collaboration quality are important moderators here. Compliance and alignment with regulatory frameworks, like the extended producer responsibility, can provide firms with access to favorable financing and lower cost of capital. And the next mechanism is related to social and CSR performance. Practices like workforce CE training helps to enhance the company's CSR image and ratings, and also build stronger stakeholder trust. But this relationship depends on CSR program intensity. At last, it's about management and control system for CE performance. So through circular economy dashboards, using LCA tools, material flow analysis, managers can make better decisions. So all these mechanisms have been examined by recent studies. And for details, you may want to read these different papers. So these mechanisms, as I mentioned earlier, relates to resource efficiency, operational efficiency, development of new business model to generate revenue streams, and so on and so forth. So in addition to the mechanisms, recent review studies also highlight the impact of CE practices on firm performance. So the major findings confirms that there are positive impacts for CE on firms' performance. So it's not just these review studies. Some recent empirical studies also found these positive impacts of CE practices on firm performance. Again, if you're interested, you can refer to these studies for details because they have examined firms' performance during different time periods and also in different countries. So synthesizing from these different studies, we found that CE positively correlates with business performance. However, this link is moderated by different factors. For example, the positive link between a circular economy index and profitability is found to be stronger for large firms by a study. And stakeholder engagement can amplify the positive effects of CE performance on financial outcomes. And it's also important to note that high upfront costs and complexity of eco-innovations can act as barriers to adoption, I think especially for SMEs.
Dr. Ho, we have 2 minutes left, please.
Right, thank you. So at last, to move the field forward, I would like to suggest some directions for further studies. First is we need to create a standard index to aid comparisons across different sectors and different companies. Second is we need multi-year panel studies and causal analysis. And the third is we may want to focus on building roadmaps for diverse sectors, including manufacturing, agriculture, services. At last, we would like to conduct robust socio-technical research to develop effective frameworks for data governance, privacy, and I think most importantly, organization adoption. So in conclusions, the AI-enabled circular economy represents the most significant opportunity for sustainable supply chain growth. And while the evidence base confirms the positive link to performance, our academic community must urgently address the challenges of governance, standardized metrics, and organizational resistance, so that we can fully develop the potential for AI-enabled circular economy. So this is the end of my presentation. Thank you very much for your